Yeah, as Amin said, hi, my name is Michael Keeling.
My name's Runde, and today we are going to be spinning you a yarn about transitioning a REST API into gRPC.
Yeah, so I don't know, it was about 9 months ago or so, Joe comes into the office and he is just ridiculously excited about something.
And I came up to Michael and I was like, man, I've been reading all about this cool new technology called gRPC. It's amazing. I think we need to use it in all of our products. Let's get on it right now. Let's go.
Okay, yeah. So I'm a skeptic by nature. Any kind of new tech, you're going to have to convince me. What is gRPC and why should I care?
All right, so gRPC is an open source remote procedure call framework. It's a newish product. It was introduced back in February 2015. It's an alternate to HTTP and REST that is a modern, bandwidth and CPU efficient, low latency way to create massively distributed systems that span data centers.
Yeah, so that all sounds nice, but we've seen tech like this before. How is this any different? Again, why would I actually want to use this thing?
All right, so the main driver is performance. Imagine we're using HTTP and REST. It's like we're playing with a garden hose, right? But we're building these services where we need to move these incredibly large payloads, and milliseconds really matter. So instead of this garden hose, we really want to be playing with a fire hose. Our services need to be drowning in data, and this is what gRPC is designed to deliver us. So how does it do this? Well, it uses the HTTP2 transport protocol underneath. And this gives you tons of advantages over HTTP1. You get these binary encodings of your messages that you can even compress for faster performance. It's using protocol buffers underneath, so there's no more slow parsing of text on either side. And the channels are full multiplex. You got multiple communication channels on one connection, streaming back and forth from client to server instead of waiting for one call, one response. It's super great.
All right, so performance is nice. Those all sound like lovely buzzwords, right? But we can do a lot of these things and get a lot of these qualities with just normal HTTP REST frameworks. Again, is there something more to this?
Right. Well, of course, being an RPC framework, you get remote procedure calls. So look, everybody has experienced the tediousness of setting up a REST client. First of all, you have to see like, oh, do I have all the required headers for this request? Did I spell them correctly? What about the JSON serializers on my views? Did I set those up correctly? The deserializers? And was the spec that I was using to do this even up to date for the correct version of the product? In comparison, remote procedure calls are way easier. All of the classes for the request and response are provided for you. So using a client is almost as easy as calling any other function in your code.
Okay, again, I'm the skeptic here. I don't want you bringing new tech into our architecture that we don't need. I can do RPC clients with HTTP and traditional REST. I don't know, performance is great, but you seem super excited. I'm going to give you the benefit of the doubt. Is there something else going on?
Yeah. So actually, I overheard some managers talking, and they're saying that they're looking for a new strategic direction for our platform. So really, what's going on now? All these teams that we're working with are stuck in this frozen tundra of no governance and out-of-date Swagger documentation. We have this opportunity to be the first team to really take this risk, move to this new framework, and make this pilgrimage to the RPC oasis. And if we do this right, we have the chance to get all of the teams on board working together in gRPC land. And everybody's going to be working together more efficient because integrating is easier, and all of our products are going to have way better performance.
All right. So this actually does sound kind of cool, right? So a lot of the quality attributes that we want, it does sound very alluring to be on the cutting edge and kind of setting the tone for our company. Tell you what, so yeah, we can give this a try, but first we're going to do a demo. So what does this actually look like?
All right, well, let me show you. So the other day, I was working on a project with my Pentium P5. And of course, I needed to do some division. And Pentium P5s, as we know, cannot divide. So I needed to call out to an external service to do my division for me. So to set this up with gRPC is very easy. So we simply define a new math service with an RPC for dividing. And we take some operands, a dividend, and a divisor, and a result, which gives us a quotient. And then with a quick, simple command, we can generate, if I get over there, this will generate all of the code required to use this service. So now I'll show you how easy it is to set up a client and a server. So if we take a look at this, this is in Go. Really, all you need is some boilerplate setup. You create a new net listener on some port, and then we just attach a service to it. And all we have to do to implement the service is copy in the generated interface for us and implement the logic. And so, OK, we're dividing. So, of course, you can't divide by 0. So, no, we have to handle this error case. But this is super easy to do. You just return no result and this gRPC error object that has a nice set of enumerated codes for you in a message. And otherwise, look how easy it is to just do the division and create this object. And then the client, oh man, the client is even easier. All we do is just do the generic dial up to a server, attach this math client to our connection, and look how easy it is. We can try to divide 10 by 4 and 10 by 0, and let's see what happens. Oh. So if we quickly build our server, run it, let it through the firewall, build our client, and run it, and look. How easy was that? In less than a minute, I set up this gRPC service that solved this problem that I had, and now my P5 is doing division.
All right, so it sounds neat. It looks kind of cool. There's just kind of one problem that we have, right? We've got all of our microservices written in REST right now. So this does seem kind of interesting. Tell you what, if you can come up with some kind of a plan, okay, that will allow us to perhaps do an experiment, take one microservice, still be able to retain the functionality that we have, and ship the additional functionality that we require on time, then yeah, no problem. Go for it.
We'll jump this horse midstream.
Jump it. Got to do that experiment first, though. So if you have...
and we also have to hit our business constraints, too.
Yes.
Yes.
Yeah.
Existing services can't go down, and we need to deliver on time. But yes, I'll tell you, I have already formulated the perfect plan for this.
How convenient.
So first off, we're going to redesign our APIs for gRPC. Then we're going to build our gRPC services, run them side by side with our REST services, then transfer over our functional tests, delete REST from our code base, and we're done. All right, so after that conversation happened, we actually followed through with our plan to swap out our transport protocol in the middle of development. So, OK, first things first, we needed to design our gRPC API. So how is gRPC different from REST? At first, it seems like it's a straightforward transformation, one or the other. So in a very simple case, we have an API that serves a foo, and we want to post, and we want to get. This is really simple. We have maybe an add foo RPC and a get foo RPC. And add takes a foo object, just like you'd send a JSON payload with a post. And get takes an ID, just like you would send an ID in the URL. But let's look at what this foo contains. Of course, what else would it contain but a collection of bars? So it may not look like it yet, but this is going to get us into a little bit of trouble. Because now we need to figure out how to post and get these bars as well. So with REST API, it's pretty simple. I'm going to post to a foo ID, the bar resource, something. Same deal with get. But there's a little issue here of these foo IDs. Now notice these RPCs don't have a place to input which foo we're dealing with. Ooh. So this sneaky little foo ID is going to have to sneak his way into bar ID, and thus also into bar. Now, so when we first saw this, we had a brief moment of like, oh god, our objects are polluting each other. This is needless coupling. Oh, the sky is falling down. We've made such a huge mistake. But that quickly passed, and we realized that, OK, well, this is just a quirk of how gRPC works. And it may look really weird, but we can deal with this. And this guy is going to stay in place for now. But this did lead us to one final interesting question. Because we encountered a few situations like this, where we have two separate services here, a bar service and a buzz service. And we have these foos that contain a bar in one service and a buzz in another. Now, because our bar and buzz objects both need to contain this identifier for foo, now we have this foo identifier defined and compiled separately in our two services. And so we kind of thought, oh, well, maybe these foo identifiers are semantically the same thing. And in that case, maybe we want to put them into a common messages proto definition and then share that across our services. But we had like tons of cases like this. And in the end, we decided we didn't want to sit down and kind of figure out all the boundaries of our contexts because we have our business deadlines. We need to ship. So we dealt with a little bit of technical debt of just having these foo IDs defined across all of our services. But we dealt with it. OK, so the next step in the plan is to serve REST and gRPC together. So our current component and connectors view for a service looks like this. We have our foobar service, and we have a single REST caller. And what we want to get it to is a foobar service that can serve both a REST caller and a gRPC caller. And so the fundamental question here is, how do we evolve our API without damaging the basic functionality of our service? So I'm going to look into the code a little bit and see how we've laid it out. So we used a basic layers approach to our architecture. So we have all of our service handlers in one package, and they're only allowed to import our application logic, and then our application logic is only allowed to import some bottom layer like data store access. Right? And because we've set up our code in this pretty simple layered pattern, it's really easy to just define a gRPC service layer right alongside our REST service layer and interact with our application logic the exact same way. And so what we found is this layered pattern made things really simple to serve REST and gRPC side by side. It was like, eating cake. And you're probably thinking like, okay, of course, like why wouldn't you ever design an API like this? Well, this was a real code review comment we got saying, what's with the service layer? This just passes its inputs over to our business logic functions. It's redundant cruft. Get rid of it. Well, okay, maybe they have a point, but I had the personal misfortune of having to refactor service handlers that were hundreds of lines of business logic long, and that wasn't like eating cake. That was like eating rotten fish. Did not like it. So besides that little bit of rotten fish, evolving our code went really, really well. But we were about to find that maybe we took the training wheels off a little bit too fast. So some things suddenly became a problem. Health checks. We have lost API/health. So now we're like, oh, we don't have a simple way to check the health of our running service. What are we going to do? API discovery is pretty much out the window. We are no longer returning hypermedia in our responses so that people can actually figure out what resources we serve. We've lost a lot of our tooling support. Like there's no curl for gRPC. There are some tools that get us halfway, but and headers, SSL, we don't know what we're going to do. And all of the community examples are really simple because gRPC is kind of new. But we're good old software engineers, and we say, those are just details. We'll worry about those later. We're going to plow ahead. OK, so the next step was to transition all of our functional tests. Now, for a bit of context, for our functional testing, we created a specification by example using Cucumber with Ruby. And this is one example of what a specification by example looks like. So these are human readable and hopefully human executable as well steps that describe how you can interact with our service. And at the end of the day, what this creates is an executable documentation of your code. But the problem is this executable documentation of our code is like tons of pages long. And we're thinking, dang, this is going to be like a Herculean effort to make all of this use gRPC instead of REST. And we were just about to sit down to write a ton of custom mapping code. And we found a couple pretty magical lines of Ruby code. So it actually turns out what we can do here is pass in the string name of a message and the name of the RPC that we want to call. And Ruby will actually return us those generated stubs of code. And then gRPC is pretty cool as well because it'll allow you to decode a JSON object into a message as long as all the fields have the same type. So we're like, ah, yes. What it turns out is actually transforming these stuffs wasn't so bad. We really just created a set of find and replace commands that did all of the heavy lifting. So you can see like it's basically all the same as our REST definitions. And the end result is that we were able to transfer over 200 of these functional tests and get them all passing in less than a week. So why did this really go so well? Well, really, creating a specification by example and using Ruby gave us this flexibility that, say, we wouldn't have had if we had done our functional testing like with JUnit using Spring to stand up our REST controllers inside our application. Like, that would have probably been a full stop right there. Like, we would not have had time to transfer our tests, and they would have shut our project down. So this was really good. OK, so finally, it's time to remove the REST functionality from our code. So we queue up this command in the terminal. Man, we are all ready to hit enter, except there's one little issue. So as it turns out, a subset of our functionality is user-facing. And it's probably not a smart move to force all of your customers to integrate with gRPC. Like, what's this? They want to use REST. They want to see stuff in their browser, right? So what's the team to do? Fortunately, GitHub is really cool. So we're going to fork our repository, and we're going to try our hand at hand-rolling a REST proxy for this bad boy. So let's go back to our layered architecture from before. We have a single service that's serving both this REST layer and gRPC layer. But we want to delete this. So after we fork it, it's going to look something like this. We're going to pull that REST service layer out into a different proxy service. And then we're going to start dogfooding our own code and writing gRPC clients for our gRPC service. And what we found was, yeah, we were right. This was super simple and easy to do. So we're really happy about that. And now we have this proxy service that abstracts away all the customer-facing functionality from our core functionality. Everything is amazing. Except then the evil wizard struck again. So it turns out we had initially picked a framework to work with, Spring, that we were very happy about because it fit all of the functional requirements for our project. But then, of course, halfway through, all of the assumptions about our project changed because we switched from using REST to gRPC. And so now we're tied into a framework that perhaps we really don't want anymore because our assumptions have changed. So this was a hard lesson to learn, and maybe we should have been a little more conservative with our choice of frameworks in the first place. OK, so now we're ready for release, right? Except we got to get back to these details. So we created these problems before, and now we have to figure out how the heck are we going to solve these things before we can ship. So as it turns out, a few of these are actually pretty easy. So for health checks, we just implemented a standard gRPC health check, and then we ship a small binary with our services that knows how to contact that can report the health of our running services. Headers are really simple too. gRPC supports metadata with all of your requests. And SSL, I don't know why we thought this would be a problem in the first place. We were just being lazy. But SSL support's really cool too. But API discovery, though, is a bit of a problem. So of course, REST services can tell you all the available verbs and explore resources through hypermedia. But what equivalent do we have in gRPC? So we kind of took the approach inspired by SOAP and WSDLs, and we created our own info service that would serve up our GitHub repository URL as well as the running version of the service. And then we snapshot all of our proto files with our releases so that a client can go right to our GitHub, pull the proto file, and then they can vendor that along with their service. So unfortunately, with this approach, it still turtles all the way down, because how do you locate the proto file for the info service? Well, this is the best we've come up with so far, though. And for the integrations that we've done so far, it's worked for us. All right, tool support, though, is our other big problem. And basically, well, maybe not basically non-existent, but we lost a ton of tools that we had that we really liked working with for REST. So like, we don't have any of the advanced mocking support, no curl. We can't do things like capture a session and replay it for our tests. But we were able to solve a few things. So we hand-rolled all of our mocks for our functional tests, which was still pretty easy because that's what gRPC is designed to do, make it easy to write services and clients. And in any place we came across like a bug, something was weird that we want to just slack somebody a curl command, well, we wrote a new functional test. So we ended up with some more coverage. So, all right. So now we're finally really ready to get on our bikes and ride gRPC into the glorious border buffer sunset, and finally leave Grandpa behind. So what interesting things did we learn? Well, so the right kinds of abstractions promote extensibility. And of course, you're going to be sitting there saying, like, well, yeah, duh. But this was an interesting lesson, interesting case study, in that we really ran up against some places where, yeah, we hadn't chosen the right patterns to begin with. And then we had these hundreds of lines long service handlers that we had to refactor. So don't leave broken windows. You might be sorry like we were. gRPC is a little bit funky because you kind of got these URIs that have to be in your messages. So if you take the time to think about your bounded context beforehand, transitioning your API might be easier. Specifications by example, those make things, but it lets you abstract your tests away from your application logic itself, so that it makes them easier to transfer when you're refactoring your applications. So those are, I think, pretty important. And then, yeah, be conservative when you're choosing your frameworks so that you don't get stuck using something that you perhaps don't want once your assumptions about your project change. And if you do decide to use gRPC, you're going to have to deal with some of the risks of new technology adoption. Like, yeah, we lost a lot of the tools that we liked, but we worked around it. So would we do it again? Absolutely. So integrating with our services was such a breeze using gRPC. I was able to make breaking API changes a week before we shipped our products. And it was all good because the remote integration team they got a notification on Slack that we released. So they went to GitHub, pulled in new protofiles, recompiled, and they were up and running again within an hour, which was in stark contrast to when Michael Keeling was integrating with some REST services, and they were like arguing over Slack, like, no, this JSON's not correct. No, your Swagger's out of date. So this also, because things were so easy to integrate, we've actually been splitting up our functionality into like smaller and smaller services where we can, which we're really happy about because that lets us choose the programming language that really fits the task best. So we're really happy about that too. gRPC also makes it really difficult to do bad things. Like there's no null. You don't have to worry about MIME types or type checking, which just makes development that much easier. And of course, the performance is like super hot. We are so satisfied with a small number of small containers handling extreme amounts of load. It's great. All right. So before I wrap up, I just have one more thing to ask of you guys. Please go buy this book. It's great. Thank you. If you have any questions.
Thanks, everybody.
Yes.
Yes, I do. You didn't mention gRPC gateway. Did you guys look at it, decide not to use it?
Do you want that one, or should I take it?
You should take that one.
All right, so the question was, you did not mention gRPC Gateway. We looked at it. We were dissatisfied with it. It didn't offer the flexibility that we required. After playing with it for several days, we still couldn't get the darn thing to work. Let's see here, the amount of time it took us to fail at getting the open source gRPC Gateway working, we rolled our own from the existing REST. In this case, we already had the gateway, and so it was just easier to use that.
So you do have your own version of it?
No, we are not using the gRPC Gateway open source project. We took our existing REST endpoints, nuked all business logic from it, and it calls directly into the backend service, whichever slide that was. We did look at it though, and it didn't really meet our needs.
Questions?
You want to give them the mic maybe? They're trying to, yeah.
So I have a little experience with Apache Avro, and I'm curious with gRPC how you handle changes to the representations, like addition of fields, removal of fields. How do you evolve those things without breaking clients?
Well, we haven't thought of breaking changes yet, like removing fields. But gRPC is fully backwards compatible, so if you add a field, the transport at least still won't break. So the clients will still be able to contact you, and you'll just see an empty value for that field. But
right, adding is fine. Removing would be a breaking API change, so don't do that. We did have to come up with some internal conventions though on our team, right? How do I indicate that this is a breaking API change? We ended up using package versioning and file name versioning to kind of indicate. how that would happen. The equivalent in REST, right? There's kind of 2 or 3 ways to do this in REST. The best way would be the kind of hypermedia way, where you would set your headers to kind of request a specific version of a resource. Nobody really does that. Instead, we do the easy thing, v2 in your URI, right, or v3 or whatever. We don't have URIs though, right, with gRPC, so it's actually baked into the proto file itself, into the RPC definition. We just have to come up with some kind of convention for your project, for your system.
So your underlying data model still looks REST oriented. It still looks resource oriented. So the fact that you had to jam those bar IDs in the foods, right? It indicates that like the underlying data model hasn't changed. Is that how you're going to keep it? Do you want that model, or are you going to evolve away from resource orientation?
So, all right, this is definitely the first version, and it looks resource oriented because it was heavily inspired by our existing REST. As we're gaining more experience with the gRPC capabilities, I think we want to start evolving away from the strictly resource-oriented nature of things. George Fairbanks talked a little bit earlier in the workshop on Monday about kind of functional paradigms within an architectural framework. I think we're starting to tickle some of those ideas here, and it seems like it's a few steps away, right, from what we've got to getting some really cool capabilities, which I don't think we'd be able to do with REST. So I don't know, it's something we're interested in, but we're learning. And Jeremy's from Google, he probably knows all this stuff already, right? But we have some people from former Googlers at our office as well, and there's a lot of best practices that those guys have developed over the years that you have to kind of, I don't know, just know somebody to find out. So I don't know, we're still learning, but.
My question is actually 2 things: performance and deployability. So in our organization, we still have EJBs. We don't write them anymore, but we have about 70 of them. Way back when we decided to create EJBs, there was that mindset, EJBs are binary, they're Java, there's no XML parsing involved, so they should be faster. At some point later, we ran some performance benchmarks, and we realized that HT using XML was pretty much the same level of performance in our context. So I appreciate you mentioned performance is a benefit, but I was playing devil's advocate. Did you run benchmarks to compare plain HTTP with gRPC? So is it really a performance benefit? Is it from a garden hose to a fire hose? Or is it just a promise from Google? That's one question. The other thing is, one challenge we have with EJBs, and EJBs is a kind of RPC technology, is you have to send a piece of code to the client, right? So deployability is a problem, or it's a challenge. And with HTTP, if you have an HTTP API, I can open Excel spreadsheet and I can call it. I can call using curl or Postman or whatever. I don't need any piece of software from you to be distributed for me to link and call. So does gRPC require that kind of distribution of a piece of stub to the clients, which would be a deployability challenge? So performance and deployability.
Yeah, so performance we are still running benchmarks on these things. What we found in cases where there's significant text, which is a lot of things that we're dealing with, we get a small performance boost to the point where we have moved a lot of our bottlenecks out of kind of transports into other areas of concern around like algorithms and things like that. Not universally true though, right? So if you're dealing with small text and things like that, it's no worse, I guess, would be the thing. Like there's no overwhelmingly positive thing. It would be neutral, kind of territory. With respect to deployability, absolutely, we harm deployability with this. But I think the advantages that we get from some of the type safety or some of the guaranteed properties with the way we deploy makes this approach highly desirable, right? So we're able to enforce some of our architectural decisions in a much stronger way with the controlling who we give protobufs to and how we kind of distribute these ideas in a way that we can't do with something that is like completely open and discoverable. So in some ways we like that, but it does harm deployability depending on your scenario.
All right, thank you so very much. Round of applause for Mike and Joe.